Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Colored Groups by Nahilion. And here are the rules. We have normal Sudoku rules apply, which means in every cell on the grid, place a single digit from 1 through 9 such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We also have to color each cell in one of two different colors, where cells containing the same digit must have the same color. So that means every digit which is the same digit must be the same color as all the digits that have that color, have that digit in it. So every 1 is going to be the same color, every 2 is going to be the same color, and they must be colored in one of two colors for each digit. And etc., etc. Every 3 is the same color, every 4 is the same color, etc., etc. If an orthogonally connected group of cells of the same color has one or more circles in it, the circled cells contain the size of that group. So an orthogonally connected group of cells means that of the same color means you can go from any cell in that color in that region to any other cell in that region just by going through edges, all while staying within that region. So if this were to be, say, like this was the coloring here, this green cell would form a region. This blue cell would form a region. Say it was like this, then. I don't know. We're going to try to form a somewhat valid one. If this was... This cannot get to any other blue cell possible through edges just by staying within the region. So it would not... This would be a total of 7 cells in this region. So these circles here would have to be 7 and 7 here, because they must count the number of the size of this region of the orthogonally connected cells of the same color. And those are all the rules. And this is an example of how that works. Of the orthogonally connected group of cells of the same color, if they have one or more circles in it, the circled cells contains the size of that group. Those are all the rules, as I said, and if you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so the interesting one here is this central box. If this were to connect to any other orthogonally connected cell here, the problem is they would have to have the same size. So this cannot be the same color as these 4 cells. So we're going to mark this as red, and we're going to mark these as blue. So these must be all blue. Now these cannot connect either because of the same reasoning, and this has to be a 1. So 1 is a red. These cannot connect because then they must be part of the same region. So these have to all be red. That means the blue has to go out this way, because it cannot be 1. Same with this blue, same with this blue, and same with this blue. We have a similarity for these 3 digits. These have to be opposite sets, right? So this could be the same as this. We're going to mark this as pink and green, though. So this is green, this is pink. The red, actually, we doesn't have to go out. It could be singletons. So we don't know about these digits. These have to be opposite. One of them could be 1. We don't know. What else do we know? Okay, so we know boundaries. Let's mark the boundaries. We'll mark them in green. So we know this is a boundary, this is a boundary, this is a boundary. Same with these. This must be a boundary, and we can't see that. Maybe we should make it red. Red is usually easier for me to see. This is a boundary here. 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 So we know those are all boundaries. These could be the same color. And the reason why these blues go out is because they have to be greater than 1, obviously, because this is 1. We have 4 blues in row 5. There are only 4 blues total in the digits. So these have to be red. So this is red, which makes this red. So one of these is red or blue. So this is definitely a boundary here. This is a boundary here. Really wish I could have a better color, but black doesn't work so well because it's with the box borders, it has a problem. Oh, these are red too. So these are red and these are red. Again, one of these is blue and one of these is red. So there's one of these is going to have a border. The red here cannot be 1 because it wouldn't be matching with this. These obviously can't be the same color, or they can't be the same region, I should say. These can't be the same region either. But these cannot be, the red here cannot be 1. If this were 1, it would have to be red, but that's already contradicted by here. So 1 cannot be any of these cells. 1 in box 4 has to be one of these 3 cells, and it has to be one of these 3 cells here. Okay. It could be here. It cannot be here. If this were 1, then this would already be a red region which has greater than 1 red region. So that's not possible. So 1 has to be one of these 2. Same with this. This cannot be 1 because if it's 1, it's red, and that would be greater than 1 red region. So 1 has to be one of these 2. Okay. What does... Okay, these cannot be red either. This can't be 1 either because it connects to this red. So this can't be 1 either. Therefore, we know this is 1 and it's a red. We know this is a 1 and it's a red. Okay. These both could be blue. These both could be blue. Okay, we know one of these is red. If this is red, okay, so say this is red and red, then this has to be blue and blue. I guess that's possible. That would be 3 then. So if this is red and red, this would be blue. This would have to be blue and blue here. If this is blue and blue, and this is red, blue and blue, this is red. Okay. So if this is, again, red and red, we have 5 reds in box 4. So therefore, this is blue and blue. If this is blue and blue here, this is red. This is blue, so this is the same region, but it has to be a different region than this, so that forces this to be red, which makes that blue. So either way, this is blue. So this is blue, which means there's a boundary there. So this must go out that way, because it can't be 1 again. So if this is blue, this is red. Okay, so this then, we have 2 blues here and 3 reds. That means we have 2 blues left and 3 reds left. So these are both the same color, because they can't be the same as that. This has to be then the same as that. So this is pink, which forces this to be green. Okay. This cannot... If this is... Pinks are both red, then these are part of the same region, which is not allowed. So... Okay. We can mark the whole border as red so that we have that. So pinks cannot be red, because then this would be the same region. So pinks have to be blue, which forces green to be red. So then this is done as a region here, and they both must be 3. So this is 3, that's 3. This is not a region here, or it's a different region. This cannot be 1, so this must be blue. So 3 has to be one of these 2 cells. Well, if this is 3, this would have to be 3, and then we have a contradiction. So this must be a 3 here. And we have 5 reds in row 4, so this must be blue. But this has to go out here to be 3. This has to be greater than 3, because it's already 3 here. So it's 4 through 9 here. What else do we have? This could be 2. This could be 2. This is at least 4. So we have 4 through 9 here. This is 2. At least. This is 4 at least, because it can't be 3. And it matches that. This could be 2. And this could be 2. This could be 2. We have a lot of 2 possibilities. That could be 2. Okay. 1. Can this be 1? No. 1 could be any of these. 3, 3, 3. We have 3 blues already in... that's interesting. We have 3 blues in row 3. We have 2 blues in row 7. One of these is blue, the other one is red. Other 2 are red. Okay. Um, these two digits must match these two digits. Okay. Um, right, because these two digits match these two digits here. But this could be the same as that, which could be the same as... Oh, no, this is the same as that digit. So we know these two digits are the same, which means it's the same as that digit there, because that's the last blue. Interesting. Um, hmm. Okay, so let's mark that. This is A. And that's A. That means this has to be B, which means it matches that, which means it matches that. So that's C, C, and one of these is C here. Okay. These two digits here must match these, which must match those two here. Okay. What does that mean? I don't really know. This could be a 1 here. That's possible. Okay, this can never be 2. If we tried to have this as 2, this would have to be blue and blue, and we'd have 5 blues in row 3. So this cannot be 2 here. So we know one of these is 2. Oh, one of these has to be 2, right? No, this could go that way, I guess. No, it cannot. This is... Okay, so that's blocked as a border. So this is red. Because they're in the same column, and they can't be the same part of the same region. So this is blocked. This is blocked. One of these is guaranteed to have to be 2 then. Because you can only go 1 here and 1 here. So therefore... So you can only go 1 blue here before going up, and then the other one's blocked. So you're guaranteed this has to be a 2, which means one of these is 2 here. That means one of these is 2. The other one has to go out and then up here. Because we have 3 blues already in row 3. What else do we have? This cannot be 1, but that doesn't really help us much. Can you have 4 blues here? Yeah, I guess. So this could actually be 1 here. This is 3. Okay, so this one of these is 2. The other one has to be blue and going out that way. So that means one of these 4 is blue, which means none of these can be blue. So this has to be red. Because again, one of these is 2, one of these is larger than 2. So that it has to be one going out that way. So this is red here, which means this is 3 has to be that way. So this is done as a region, which means both of these are red. And we have 4 reds in this box. So this is at least 6. 1, 2, 3, 4, 5, 6. Actually, it has to be greater than 6. Because at least there's only one blue here. So that one of these is at least red here. So this has to be 1, 2, 3, 1, 2, 3, 4, 5, 6, and one of these is 7 at least. This blue has to go out this way though. Okay, so then so therefore that forces both of these to be red. So that's 1, 2, 3, 4, 5, 6, 7, 8. We can only have one more red. So if this is red, that would form a orthogonally connected room of 10 at least, which is not possible. So this is blocked. This is blocked. This is blocked. So this cannot be red. This is blue. So that forms a cell by itself. You could have 2 reds here, or sorry, 2 blues here. That is possible. Oh, we have 5 reds in column 8. So that means the rest of the column is blue. So this is a border. This could be blue. So either, so this is 1, 2, 3, 4, 5, 6, 7, 8. Either this is blue, and you could have a red somewhere here. Or this is red, which would force this to be blue. So one of these two is blue, which means the remaining digits in this box have to be red. So these are all red, and this must be 4 then. So these are 4, which eliminates 4 in the rest of the row and box. One of these is a 2. So this is done as a region. This has to be 4 as a region. So that's 4 because one of these is blue. This is boundary. We have boundary here. This is 8 or 9. One of these is 2. We're not sure which. This has to be at least 5. That's interesting. So one of these is red, one of these is blue. If this is red, this becomes a blue-blue pair. This could still be blue and blue. Okay, so if this is blue, obviously this could still be blue and that's red. That's possible. So we're guaranteed 1 blue in column 6. Okay. So this cannot be 3 blues there. But it could be blue-blue here and this is red. So this doesn't have to necessarily connect with that region. This is 4. So it has to contain 3 blues in box 7, which means the other blue is not connected. Interesting. Hmm. Okay. 4 has to be one of those 2 digits here. 3 is one of these 3. Oh, 3 cannot be here. Where is the 3 in column 7? It has to be one of those 2. 3 has to be one of these 3 here. So this is guaranteed to be 3. One of these then is a 2. We're not sure which. We have 2 and 4. We don't know what the last digit is for the blues. So this is 5 through 9 here. This, we're not completely sure. This cannot be 1, cannot be 2, 3, or 4. It's 5 through 9 also. Interesting. So these 2 digits match these 2. Okay, that's not telling us much. These 2 obviously match these 2. These 2 match these 2. So we have B here, here, and here. C here and here. I don't know. We'll go label this D and E, I guess. D, E. Have to be D and E here. D and E match D and E here. This is F and G, which makes this FG pair, FG, FG. So this is D and E, guaranteed. This matches one of these 2. This matches one of these 3. We don't know which. Okay. So again, only one of these 4 is blue. And then it has to go up. Okay, so if we try to make this blue, and then that goes up, this would be red, guaranteed. This would be blue, blue at... I guess it could connect here. Oh. Dang it. Okay. Oh, this cannot... If we try to go blue here, and then blue here, the problem is that's 4 blues already in column 1, so this would be red, and this would be blocked off, and this would have to have a 4 in size, which is not possible. So this cannot be blue. This is red. Okay. This could be the same digit, so this could be fine. This could be blue, blue, blue there. It could be blue, 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 blue there. So that's potentially fine. I mean, it could be also 3 in box 2. In box 1, that's not possible. But, or specifically staying only in box 1, and that's not possible. Okay, this must connect one of 2. It could be here. Could be here. Could be, so 1, 2, 3, 4 could be that way. Is that possible, actually? So if this is 1, 2, 3, 4, that would force all of these to be red. We'd have 1, 2, 3, 4, 5, 1, 4, 5, 6, 7, 8. This could be a blue, I guess, that blocks it. And then this would have to be blue. Actually, not necessarily. This could be just red, red, and that would be blue. No, this cannot be 3 blue. So yeah, if this is all blue that way, that forces these to be red. This cannot be 3 blues that way because of the 2 blues already in the column. So one of these is red, which would force this to be blue. And then that would be 1, 2, 3, 4, 5, 6, 7, 8. And if we connected, that would be 9, 10, which is not possible. So if we go 4 blues here, again, this has to be red. One of these has to be red at least. Therefore, this must be blue. We have 5 reds in box 1 already. And this cannot connect because that would be 10. So this must be blue, which forces the rest of this to be red. 2 blues here and 1 red. So it cannot be, well, I guess it could go this way. No. If it goes blue here, it has to go blue here. Otherwise, this is red, which would force both of these to be blue. So this is blue no matter what. So far, this is looking fine. Okay. One thing we know about column 5 is this has to be a 3-4 pair here. Because we have blue as 3-4. These are the remaining blues here. So this must be 3 and 4. Um... So that's okay. If we have 4 blues here, this is blue. What happens if we have blues here? Then these all must be red. That's interesting. That forces this to be blue. This is 1, 2, 3, 4, 5, 6, 7, 8. And if it connected, that would be 10, which is not allowed. So this would have to be blue, which would force red to be here. This would be blue. This would be blue. It cannot be blue here, so this would have to be blue. And that seems fine also. Okay, what happens if we go blue here? So if blue's here, we have 4 blues in column 2. This has to be all reds to be connected. This is red. One of these at least is blue. We don't know if all of them are. One of these, so this would be blue, blue. So that would force red to be here, here, and here. So that would be blue. This would then be 2. Oh, that's interesting. So the only way this is not 2 is if this goes this way, right? So say this was 2. If this is 2 and this is not 2 here, that would mean blue has to go out this way. This would be red and red. This would be 9. So these would have to both be blue. Aha. And then we'd have a contradiction in row 2 because we have 5 blues in row 2. Because this cannot be orthogonally connected to another. Oh, even then it connects, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's... So this can... there we go. So we know this can never be red because if it's red, it connects all of these, and that would be 10 as an orthogonally connected region. So this has to be blue. Since this is blue, the rest of the digits are red in row 3. And this must connect up because it cannot be 2 anymore. So this is blue, blue. This is red. So this has to be 2, and this has to be 2. So then this is red, red here. Border, border. So this is red, and this is red. I guess this could be blue, blue. Oh, it cannot be blue, blue here because we have 4 blues, or 3 blues already in column 6. So only one of these could be red at most. Sorry, one of these has to be red, and it has to be a red-blue pair. Which means this is going to be at least 6. 1, 2, 3, 4, 5, 6, 7. Sorry, 7. Therefore, one of these is blue. Since one of these is blue, this cannot be blue. Because one of these is guaranteed to be blue because we have 4 reds already in box 8. So this is 3 blues here, 4th blue here, this is red. And this has to be at least 5. Because it can't be 3 or 4 or 2. And it has to be exactly 5. So therefore, all the blues are 2, 3, 4, and 5. So this is 5. This has to be 2, and this is 5. So that makes that 3. This can't be 3. This is a red. So this is boundary, 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 boundary. This is the same as E, so this is E also. We have 1, 2, 3, 4, 5, 6, 7, 8. This can't be 5. So this is 6, 7, 8, and 9 also. These 3 are connected. So this is 2, 4, and 5. And this is 2 or 5. So this is 2, 3, or 5. This is 2, 3, or 5 also. This is 1 red, so these both have to be blue. Okay. So then this is border. So this is 1, 2, 3, 4, 5, 6, and 1. So it's 6 plus 1 is 7. So this is guaranteed to be a 7 here. This has to be a 2, 5 pair. Okay. What happens if all of this is double red? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 digits. So it cannot be both reds here. Therefore, one of these is blue and one of these is red, which means we have 4 blues in row 2, so this can't be blue, this is red. So these are the same, which means this cannot be the same region as this because this is E. So this must be a blue, and it must block off somewhere. We have 1, 2, 3, 4, 5, 6, 7 at least here. So this is at least 7. This has to connect here. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9. So we know this is 9, and these have to be blue. Oh, well, we already knew that then. So this is blocked off as a region here. That means this cannot be 9. This can't be 9, and this can't be 9. So 9 cannot be here, 9 cannot be here. Where's 9 in box 5? It has to be here. We have 1, 2, 3, 4, 5. Okay. Remaining digits. So 1, 2, 3, 4, 5, 6, 7. It cannot connect to here. 8 and 9. Because it's this, we already have a 9 in the column. So this must be blue, which means we have 4 blues in row 7. So this must be red, which makes this blue. So then this is a region. This is blocked. This has to be at least 6. So it must go down here. So we have 1, 2, 3, 4. This is a boundary. This is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is a 9 here, which means 9 cannot be a here in columns in box 6 and here. So this must be a 9 here. So this must be D. This is not E, this is D. So that matches here. 9 is here. Okay. Where is 9 in column 5? Can't be here because of the 9 in the box, so it has to be here. So that's 9. So this is D here. So we have this is D and this is D. This could technically be D also. So we have 1, 2. And it cannot be 8 because we have 5 reds at most in box 7 and this is blocked off. So this cannot be 8, it's 6 or 7. This is 5. Okay, we have 9 here. 4, 5, 6, 7, 8, 9. This is 1, 2, 3, 4, 5, 6, 7. And it could be an 8th. We don't know. This is 7. Okay, so this has to be a 6-8 pair here in column 5. That leaves this as a 1-7 pair here in box 2. This can't be 4. This is a 2-5 pair here. Why can't it be 4? 4 could be here. This is 2, 4, 5. This can't be 4, so it's 2, 3, or 5. This can't be 3. This is 3, 4, 5. This can't be 3 or 5. It's 2 or 4. Okay, and this is 2 or 5 here. Okay. So one of these two is blue. We have, okay, one of these two has to be blue to be a form region. That means we have 2 blue here, 1 blue here, and 1 blue here. That eliminates blue in the rest of the row, so this cannot be blue. This is red, which forces this not to be red, so that's blue. So one of these is blue. We have 2 blues here. No, 3 blues here, and 1 more blue here. Okay. Only one of these is blue, one of these is red, but it could be a blue-red pair here, opposite. Where is 3 in row 1? It has to be one of these digits here. Because it cannot be here, cannot be here. So 3 in... This cannot be 3 here. Where is 3 in row 3? It has to be one of these 2. That's not telling us much. This is 2, 3, or 5. We have 1, 6, 8 remaining in red cells. In box 8. Okay, so let's just remove F and G. It's not very helpful. D is helpful, but okay, so 6, 7, 8. 6, 7, 8, 6, 7, 8, 6, 7, 8, 6, 7, 8. 9 cannot be here. This is 1, 6, 7, 8 here. 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 And one of those could be 9 here. So 1, 6, 7, 8, 1, 6, 7, 8, 1, 6, 7, 8. We have a 1, 6, 7, 8 quadruplet in row 1, which eliminates 1, 6, 7, 8 in the rest of the row. Therefore, the last red in row 1 is a 9. And it must be one of these 2 cells because it cannot be that cell because of a 9 in the column. So the 9 has to be one of these. Therefore, this is 8. So all the D's are 8. So this is 8, which means this can't be 8 here. This can't be 8 here. No 8 here. No 8 here. No 8 here. This 8 eliminates 8 here, so this is 6, this is 8. And the reason why this is 8 is because the 9 has to be connecting to this orthogonally. So this is blue. We have 4 blues in column 3, so this must be red. This can't be 3, so this is 2, 4, or 5 also. That means in row 1, we have left with 3 and 9. Okay. This 8 eliminates 8 here and 8 here. Where is the 8 in box 3? It has to be here, so this is 8, which eliminates 8 in the column. That means one of these 2 is an 8 here. 8 has to be one of these 2. 8 cannot be here, so 8's one of these 2 here. This can't be 7 because of a 7 in the row. This is 1, 6, or 7. This could be 1, 6, 7, or 8. No 7, though, because of the 7 in the row. So this is 1, 2, 3, 4, 5. How does this work? So this could be blue and blue, which would make this 6, and red and red. Where is the 9 then? In row 7, it has to be here. So this is 9, which means one of these is a 9 here. 8's one of those 2. We could have blue here and blue here, or blue here and blue here. So if we have blue here and blue here, that means this is red, and this is 6. and this is red because it doesn't connect orthogonally. If this is blue here and blue here, this is red, and that red here connects and it forces this to be 6. So either way, this is 6. So this is 6, 1, that's 8, that's 7, 6, 7, which makes that 6. This can't be 6 or 7, it's 1, which means this can't be 1 or 6. It's, oh, we have a contradiction. Ooh, that's not good. How did we run into the contradiction? That's bad. That's really bad. Yeah, I think this logic is sound, but then the problem is we run into this contradiction. This has to be 1, which forces this not to be 1. That's 7, this is 1, which makes this 6 and 7. This 1 eliminates 1 here, so it's 6. That forces this to be 7. But that's not going to work, because then the blues are by themselves. Oh, what did I do? I'm so close. I'm so close, but I made a mistake somewhere. Maybe it's I don't think it's the 9 assumption. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh. Where did I mess up? Dang it. I don't know if I want to go all the way back looking for this mistake. Okay. This is the same. These cannot be the same. So they're okay. Any circles cannot be in the same region as any circles in the same, that is, it's in the same row, column, or box. So we're making this red, therefore all of these are blue. Again, if they would connect, that doesn't work, so this has to be all blocked off here. This is then 1, because that's the size of its orthogonal connected regions. So none of these could be 1. These all have to be red. So the blues have to go out. Blues have to go out. We have 5 reds and 4 blue digits. Therefore, the rest of row 5 is red. The rest of column 5 is red. Red, these are opposite cells. We need a 1 somewhere in row 4 and 1 somewhere in row 6. If we try to have 1 in either of these, that doesn't work, because that's size greater than 1 for the reds. Same with this. So 1 has to be one of these. If this is 1, it's size greater than 1, so that can't be red. If this is red, that's size greater than 1. So this must be red and a 1. Same with this. These can't be 1 because of 1 in the box. If this is red and 1, that's greater than 1 in size. If this is red and 1, that's greater than red in size. So this has to be red and 1. So these again are opposites. If this is red, so again, we have 3 reds. These have to be opposite colors. If we have red and red, obviously this is blue. If this is blue and blue, this can't be the same set as this, because then they would be in the same box and have to have the same number in them, which is duplicate, so that's not possible. So these are opposite, which is opposite from this. So these are the same, but they can't be both red, so they're both blue. So this is blue, blue, which forces this to be red and red. That forces this to be blue and this to be blue here. This cannot be 1. This cannot be 1. This cannot be 1, so they have to all go up here. Okay. So we have boundary here, boundary here, boundary here, boundary here, and boundary here. Right, we need a boundary, the edge. Okay. This is blue because we have 5 reds in box 4. So the blue is greater than 1, so it has to go down. This is done, so this has to be 3 and 3. It's the size. This has to be greater than 3, but cannot be 2. Where is 3 in row 4? Can't be here because the 3's in the boxes. Can't be here because that's the same as this digit for the size, so it has to be here. So this is 3. And again, only one of these could be 2. So since only one of these could be 2, one has to go to the left. This can't be the same because they have circles in the same region. This is obviously not the same. This is not the same. So this has to either, the non-2 here has to go here and then go up because it can't be 3 either. So that means one of these 4 cells is blue, and we have 4 blues then in row 3. So these cannot be blue. This is red. So this goes blue here. We have 4 blues in... I guess it could go blue here, technically. Okay, so this is still, we don't know. This has to blow blue there, then that's 3 blues, and that's done as a region. So then we go there, that's blocked off. This has to be red and red. And we have 4 blues in box 6, so this must be red and red. We have 5 reds in column 8, so that means the remaining digits are blue. So this is blue, this is blue. We have 1, 2, 3, 4, 5, 6, 7, 8 digits in the red region. If we made this red, that would make a 10 cell region. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is, or greater. So this cannot be red. This is blue, which forces the reds to be in the rest of row 3. So this is blue, which means this cannot be 2. This is 2 here. So that forces this to be 2. That's 2. This is done as a region. This is done as a region. So therefore that makes these both red. This could be blue here. I think this logic still holds though, right? We have 1, 2, 3, 4, 5, 6, 7, 8. Either this is blue or this is blue, right? You can't have all reds here. 1, 2, 3, 4, 5. Oh, you can't have, you have to have one of these as blue anyways because we have 3 blues in column 9. We need a 4th blue. So this is a 4th blue, which forces this to be all red. Not all blue, all red. Which does force this to be 4 and 4. Okay. So this is done. This is blocked. This is blocked. Maybe it was logic problem was there. Okay, so this is guaranteed to be red. Okay, this is done. This is done. That's done. This has to be greater than 4, so it has to go here. We cannot, yeah, okay. Right, you can't have 2 reds here because that would be 6 reds in box 8. So one of these is blue, which forces this to be red here. This cannot be 4, it has to be 5. And then we have 4 blues in box 3, so this has to be red. So that's all done. So that's borders. Border, border. This is all border. This has to be red, because if it were blue, it would be the same region. You cannot have both of these red. If these are both red, then you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 in a region. So one of these is blue, which means we have 4 blues in row 2. This can't be blue then, so this is red. Therefore, this connects to here. This cannot connect to this as a region because these would have to be the same digit. So then it's blocked there. That's blue. This cannot be 4, so it has to go out somewhere. It has to connect to here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is a blue. So these are both 9. Okay, this is border. We have a border here. This is 5 in size. So this is 2. This can't be 2. This is 5. This has to be 4. That's 2. This is 5. That makes that 3. This has to be 4 in size because it connects to here. So this is 4. We have 5 reds in column 4, so these are both blue. So this goes red here. 9 cannot be here or here, so this is 9 here. This is a border here and here. So this is going to be... Oh, I missed one. That's where I messed up. Okay. There we go. So this is 1... Did I? Yes, this is 1... Okay, that's where I messed up. 1, 2, 3, 4, 5, 6, 7, plus another one, which is 8. So this is 8. And that's where I messed up. Because I forgot... I missed this red cell here. Okay. Well, there you go. So that was a problem. Where's 9 in column 5? This has to be 9. Because it can't be here because of 9s in the boxes. So that forces this to be a 6, 7 pair here, which forces this to be 1, 8. Which gives us probably much better things. Okay, so this is there. This is blue. I think we... So why was this not blue? Oh, wait. So this is 1, 2, 3, 4, 5, 6, 7. And if this is red, that would be 8, 9. And we can't have that 9 as a region. So this is blue. That's the reason why. So this is red. That makes this blue. Okay. So, yeah, I messed up. Oops. I messed up counting here. That was a problem. Okay. Good to know. This is red. This has to be red down here. So we have boundary here. Again, this is 6 or 7 at most. Actually, we know one of these is blue, one of these is red. Because it cannot be both red or both blue, because then this would be 5 in size, or this would be 3 in size. So one of these is blue, one of these is red. We have 4 blues in row 8, so this is red, which forces this to be blue. Okay. So this is 3 or 4 here. 3 or 4 here. Okay, so we have 1, 2, 3, 4. So then this becomes 1, 2, 3, 4, 5, 6, 7, 8, 9 in size. So this is a 9, which means 9 cannot be here or here, so 9 has to be here. Where is 9 possible in row 7? Can't be here, 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 or here because of the 9s in the column, so this must be 9 here. Where is 9 in row 1? And then we have the same thing, right? 3 could be there. Oh no, where's 3 in row 1? Can't be here, can't be here, so 3 is guaranteed to be one of these 3. It cannot be there, so this becomes a 3-9 pair. One of these is red, so that's 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 and 8. Okay, this is boundary. This is boundary. So this is a 3-9 pair. Again, we have 1, 6, 7, 8 in the reds. But this can't be one. We have a 1, 6, 7, 8 quadruplet and 3 9s here, so that makes this a blue. We have 4 blues in column 3. That makes this a red. So this is done here. Okay. And I think this has to be 6 then, right? Because if this is blue, this is red, red, and that's blue. If this is blue, this is red, red, and that's blue. Either way, you only get 1. So 1, 2, 3, 4, 5, 6. So this must be 6 here. Okay. This has to be 8 because there's no other place for it in box 5. So that makes this an 8 here. So this is 6, 7, 6, 7, 6, 7, 6, 7, 6, 7. 8 eliminates 8 here, so this is 1, which makes this 8. Where 8 cannot be here or here in box 3, so it has to be here. So this is a 1, 6, 7 pair. Okay. And 8 cannot be here. Where is the 8 in column 9? It has to be here. So this is 8, 1, 6, or 7. This is 1, 6, or 7. 1, 6, or 7. This can't be 6 either in these bases, so this is 6 here. That forces this to be a 1, 7 pair. This 1 eliminates 1 here, so this is 7. This is 1. 7 eliminates 7 here, so it's 6 and 7. This can't be 6. So 6 is one of those two. That's fine. 8 cannot be here. 8 cannot be here, so 8 has to be here. Therefore, we have a 1, 7 pair in column 3. This has to be a 2, 4 pair in column 3 also, because this is 3 and 5. That leaves this not as 3 or 9, so it has to be 5. That leaves this as 2, 3, or 4. This is 2 or 4. This is 3 or 4 because it can't be 2 or 5. We have a 3, 4, 3, 4 pair in row 7, so this is 2 and 5 and 2 and 5 there. This 4 eliminates 4 here. So this is 2, 3, or 5. This can't be 3. This is 2 or 5. And this is 2, 3, or 5. 2. This cannot be 3. It could be 2, 4, or 5 here. And this is 2 or 5. We have a 2, 5, 2, 5 pair in column 8, so therefore this must be 3. That leaves this as 2 or 5 here. This has to be 2, 4, or 5 here. One of these is 4, but that doesn't help us much. This is 1, 6, or 7. This is 6, 7 as a pair. This has to be, cannot be 1, it's 6, 7 here. We have a 6, 7, 6, 7 pair in column 1, which eliminates 6 and 7 in the rest of the column. This can't be 6 or 7, that's 1, which makes this 7, which makes this 1. That eliminates 1 as a possibility here and here. Whereas the 1 in box 9, it has to be here. So that's 1. Eliminates 1 here. Where's the 1 in column 9? It has to be here. Okay. We have a 7 remaining here. So one of these is 7. We have a 9 remaining here. So one of those is 9. And then the rest are 2, 3, 4, 5. So this cannot be 2 or 5 here. This can't be 4. This can't be 3. So those are the remaining digits possible. This is 7, so this can't be 7. This is 6, which makes this 7, which makes that 6. 6 eliminates 6 here, so it's 7 and 6, which makes this 7 and 6, which makes this 7 and 6. So 7 cannot be here. Where is the 7 then in box 7? It has to be here. So this is 7 as a red. And these has to be blue, which forces this to be 4 blues. So this is red, which makes this 9. And this has to be blue. Cannot be 4 or 9. So this is 3, which makes this 4, which makes that 3, which makes this 4, which makes that 2, 3. This can't be 4. This 2 eliminates 2 here, so it's 5 and 2, which makes this 5 and 2. 5 and 2 eliminate 2 and 5 here, so it's 4. 2 eliminates 2 here, so it's 5, which makes this 2, which makes this 5. 2 eliminates 2 here, so it's 4 and 2. This is not 3, 4, 5, so that's 2. This is not red, so this is blue, and this is red. So then we have all the regions. So this is done. This is done. This has to be 4 and 5. This must be 4. That's 5. 7 eliminates 7 here, so it's 6 and 7. This 9 eliminates 9 here, so it's 3. And this is 9. This miscounting was a problem. Oh, well. Yeah, pretty fun puzzle, actually. The logic behind it was very solid. It was very nice throughout. I just wish I hadn't miscounted this. That was a problem. Oh, I guess we didn't get that boundary too. But pretty cool. Nice idea and very well executed, actually. Again, I just wish I hadn't miscounted this last part here. But yeah, it is what it is. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.